somebody fumbles the ball. Ooh. The ball is rolling around on the ground. What happens, Xavier? To trap the ball. All right? Football player jumps on top of the football. What's the next thing that happens? Called?
A dog pile.
It is called a dog pile. Next time, please roll out your hands so I know who I'm talking to. All right, a dog pile. Right. So I want you to imagine that you are the guy on the top of the dog pile. Are you feeling a lot of pressure, Servando? No. Let's imagine that you're the guy too deep in the dog pile. Are you feeling more or less pressure than the guy on top?
More.
Let's imagine you're the guy on the very bottom of the dog pile. You have about 8 300-pound linebackers on top of you. What are you feeling then? What are you feeling? Yes, what are you feeling? Go ahead. More pressure. Now, what do you think this dog pile analogy has to do with the swimming pool question we were just talking about? Does that give you any kind of clue, Mr. Randall?
Maybe when you're at the top of the pool, you don't get that much pressure. When you're at the bottom, you get some more pressure.
Now, what's causing the pressure when you're at the bottom of the dog pile? Yes?
Weight.
The weight of what?
The people on top.
So what do you think might be causing the pressure? The bottom of the swimming pool.
Water.
What about the water?
It's causing the pressure.
What about the water? What about the water, Cece?
So a lot of pressure is going on you. And
Yes, but where's that pressure coming from? Am I feeling any pressure there?
yeah,
Where's it coming from?
from the top of the pool.
From the top of the pool. The people up there swimming on top? Interesting. All right, I want you to keep that scenario in mind as we go through a demonstration. Okay. So okay, any predictions? What stream of water do you think is going to go the farthest, Susie?
The bottom hole.
Bottom hole?
The top.
The top hole? The top hole?
Bottom.
Hey, so what are you noticing? Which one has the most force of energy behind it? The bottom. Okay. Now, if you notice, as time passes, is it losing or gaining energy? Losing energy. And what's pulling the water out? Gravity. Okay. And now we're down to explain. So we're going to talk about what we observed, and then we're going to try to go ahead and pass those out. Try to explain it. So discuss, confer with your team in a nice, quiet voice. What you saw, why it happened. Now you talk to your team. Why did that happen? Why do you think that happened? What did you see? What did you hear? What did you notice? How did the behavior change? And then you do your explaining after your observations.
Because the bottom had more pressure.
Okay, why though? Why did the bottom one have more pressure? Yes, ma'am. It says, we observed that the water at the bottom hole was shooting farther when the water depth was very deep. The water of the middle hole was not shooting as far, but was still shooting farther than the top hole. The top hole had the least force upon it. Okay, do you agree or disagree with these observations?
I know why the top one didn't without that.
Why is that?
Because the bottom, now I find out the question to the answer. I was looking for the bottom, the reason it's is because it has water pressure on top of it, which is pushing it down in the middle.
So water's pushing?
And it has this much, and that's pushing down on the middle. And the bottom has like this much, that's pushing down, and the surface only has this much.
Okay, so you surmise that it does have to do with the amount of water above whatever it is that's feeling the pressure, right? But the only thing I have a question about is using the word pushing. Because you're making it sound as if there's something above the water pushing it down. Does that make sense? What is making the water go to the bottom of the pool? Is it a pushing force, Christopher?
Probably the weight.
The weight, and what is weight?
It is
What does it say weight is?
how much gravity.
Ah, gravity. I said pushy things. What does gravity do?
It pulls.
Poles. All right. And where's that pole of gravity coming from? So you see? What is the source of gravity on our planet? Katrina? What is it? Where?
To the ground.
To the ground. What is it? Where's that gravity coming from? Where's it coming from? Celia?
Inner core.
Ah, it is the core of the earth that's pulling, right? So is the water that's on top of you being pushed on you or being pulled on you?
Pulled. Pushed.
I'm asking you. Why don't you guys ask your table? Is the water, if you're at the bottom of the pool, is the water being pushed on you from above or pulled on you from below?
If it was pushing you, you would have been up and up and up. And you would get on the surface.
Oh, interesting. I like your example. Okay, so what I'm going to do is I'm going to draw an illustration. I'd like for you to draw along with me. And hopefully you'll remember what we talked about with the dog pile.
A dog pile.
And see if this is going to help clarify Xavier's idea a little bit more for you. Think swimming pool. All right, so imagine there's concrete all around. Yes? Okay, here you are. You're swimming about 2 feet down.
2 feet.
Now,
I'm drowning.
are you feeling a lot of water pressure?
No.
No. Why? Why is that, Tony?
Because you're not as down where it can hurt.
So you want us to look at what? What's below us or what's above us? What's causing pressure on this person? What's below him or what's above him? Servando? What's above him? So let's go ahead and see what is above him. And he has this much water sitting on him, right?
Yeah.
Okay, so it's like if you had a 2-year-old sitting on you. Are you going to feel it?
No.
You're not going to feel a 2-year-old sitting on you?
Yes.
But is it going to feel a lot of pressure?
No.
No. This stay on top of you. What is that something? Yes, Rhonda? Gravity. And gravity pushes or pulls? It pulls things down towards the core of the earth. Now, this is the gravity pulling. How do we measure gravity? What do we call when we measure gravity? What is it called? Yes. What is it? Weight. So is it true that the water on top of you has some weight?
Yes.
The mass of water, this volume of water, has weight because gravity is pulling on it, right? Good. So we've increased the volume and the mass of water. So what's going to increase along with it? The gravity and the weight. So now we've increased the weight. So now instead of having a baby sitting on top of you, you have a teenager sitting on top of you. Okay? What have you noticed? An increase in what? Yes. What?
Weight.
And that causes what? Pressure. So you're going to have more pressure here, right?
Yep.
So now you see all the water from here to here is now on top. It's like a sumo wrestler is on top of you. So, since the volume of the water has increased, the mass of the water has increased. Since the mass of the water is increased, the amount of gravity on the water is increased. So that means the what? The weight has increased. So, what?
Drowning.
More pressure. Good. So, what does this have to do with our experiment, or exploration, I should say?